Hello everyone, this is Dr. CJ Tak and today we will discuss in this video about the characteristic of the suspension in the chapter coarse dispersion in the subject physical pharmaceutics 2. So first we will see over here in this chapter the characteristic of different types of suspension and their differences. So mainly there are two types of suspension we have on the basis of their behavior and on the basis of their nature. We can say there are the two types of suspension, deflocculated system and flocculated system. So over here we will see the difference in between them. The deflocculated system, it will have the pleasant appearance because of uniform dispersion of the particle. Here the dispersed phase, it will be distributed in throughout the dispersion medium. So that's why the uniform dispersion, the dispersed phase that has been dispersed throughout the dispersion medium, that means solute has been dispersed in a solvent. So that's why the appearance that is pleasant, it means it looks like a uniform. Then in case of flocculated system, it's somewhat unsightly sediment and clear supernatant layer. Here initially when the flocculated system will be formed, so at that time the sedimentation process will be started. So that's why the supernatant layer, there will be not any presence of solute molecule. So that's why it will look like a clear layer and the slight unslide sediment will be observed in our product. Then in case of deflocculated system, supernatant remain, it will cloudy, whereas in case of flocculated system, supernatant layer, it will be clear, because here the sedimentation rate in case of deflocculated system, that is very low. So that's why the supernatant layer, it will remain cloudy, whereas in case of flocculated system, rate of sedimentation, that is very much higher, so that the supernatant layer, it will remain clear. Then in case of deflocculated system, the particles, they will experience repulsive force in between, and whereas flocculated system, it will show the attractive force. Here the van der Waals force is very less, van der Waals attraction force that is present in between the flocculated system. Then in case of deflocculated system, particles, they will exist as a separate entities. They will act as a different separate entities, and whereas in case of flocculated system, here the loose aggregates will be formed. Particles will form one of the aggregation and they will remain in a clump. So that's why the flocks will be created in case of flocculated system, whereas in deflocculated system there is no such like flocks, and the particle, they will act as a separate entities and it will settle also as a separate entities. Then in case of deflocculated system, rate of sedimentation, that is slow, as the size of the particle, that is small, as the particle, they are acting as a separate entities. So due to that, the particle size is low, and also we can say the size of the density of the particle, that is also low, and so due to that the rate of sedimentation, it will be slow in case of deflocculated system. Whereas in case of flocculated system, the rate of sedimentation, that is very high, as the flocks, that are the collection of the smaller particle. Small particles, they will come closer, and due to that the aggregation will be formed, so that overall the size of the particle, that will be higher. Due to that the density, that will also be increases, and due to that we can say the rate of sedimentation in case of flocculated system, that is very much higher as compared to the rate of sedimentation in deflocculated system. Then in case of deflocculated system, particles, they will settle independently and separately, whereas in case of flocculated system, the particles, they will settle as a flocks. Then in case of deflocculated system, the sediment is closely packed and form a hard cake. Here in case of deflocculated system, the system, it act as a separate entities. So due to that they will form a close packing, and once the packing is closed, see, in case of closely packing, the voids in between the higher particle that will be filled by the smaller particle, and due to that we can say the closely packing will be achieved and the cake will be in a hard form. Whereas in case of flocculated system, the loosely packed and network and hard cake cannot form. Here the aggregation, or we can say the flocks, it is going to be sediment, so the loose packing will be there, and so that hard cake, that is not possible in case of flocculated system. Then in case of deflocculated system, the hard cake cannot be redispersed, as the hard cake that has been suppressed by the other sedimentation. So that's why the hard cake, that is not easy, or we can say it cannot be redispersed, whereas in case of flocculated system the sediment is easy to redisperse. Now if we are considering the potential energy curves, then here deflocculated system, it represents the primary minimum in the deflocculated system, whereas in case of flocculated system it represents the secondary minimum. Now in case of deflocculated system, bioavailability, that is relatively higher, as the particles, they are acting as a separate entities. Here the particle size, that is very low, and the surface area, that is very high. So that's why we can say deflocculated system, the bioavailability, that will be higher as compared to the flocculated system. Whereas in case of flocculated system, the bioavailability, that is comparatively less. Here we are comparing to the deflocculated system. So these are some of the characteristic of the suspension, or we can say the difference in between the deflocculated system and flocculated system. See, this one is a potential energy curve. Here we can understand where is the region of deflocculated state and region of flocculated system. See, the graph has been plotted in between energy of interaction in versus the particle distance in between the particle. See, on x-axis there is a distance in between the particle. On x-axis the particle distance in between the particle, that is going to be raised. So if we are considering about the deflocculated system, then this one is the region for the deflocculated system, which is represented by the primary minimum. Here the particle, they are forming the hard cake, and due to that they are not easy to redisperse. Whereas if we are considering about the flocculated system, then over here the flocculated system, it shows, or it represents the secondary minimum. Here the loose aggregation, that is formed, but we can say the particle, the distance in between the particle, that is very much higher, or we can say the distance in between the particle, that is nearly 1000 to 2000 angstrom. So on the basis of potential energy curve, we can say these facts about the deflocculated system and about the flocculated system. We will see this in a detail. First one, deflocculated suspension. Here in case of deflocculated system, the particles, they possess some charge. That means some charge, it will be present on the particle. So due to the presence of the charge, there will be the repulsive forces in between the particle. So these forces, it will create a high potential barrier, and due to this high potential barrier, it will prevent the aggregation. So due to this, the aggregation will be prevented, and this is denominated with the primary minimum in case of deflocculated system. Here the rate of sedimentation in case of deflocculated system, that is low. During storage, as per the size and density, there will be the sedimentation. Here what happens, first the higher size particle, naturally we can say the density, which have the higher density, the particle, it will show higher rate of sedimentation. So once the higher rate, or we can say the higher size particle, it will be sedimented, then afterwards the small size particle, it will be sedimented in between the voids that is present in between the higher size particle. So due to such type of pattern, it will show the close packing. Then afterwards, once the we can say over here in case of deflocculated system, first layer, when it comes to the ground state, or we can say it will be sedimented. Afterwards the second layer it will come, then afterwards the third layer it will come. So due to that, the lower layer, it will be affected by the higher layer, and due to that it overcome the energy barrier, and the strong attraction forces will be built up in between the particles that has been sedimented at the bottom. So due to this, it will form the hard cake. So primary minimum, or we can say the energy barrier, if we are considering the potential energy barrier, then it will be overcome when there will be the sedimentation in case of deflocculated system. So due to that, the hard cake will be formed, and such type of hard cake, it will not be redispersed, or we can say the redispersion, that is very much difficult in case of deflocculated suspension. So this is one of the disadvantage in case of deflocculated suspension. Otherwise, we can say the bioavailability, that is very much higher as compared to the flocculated system. Then in case of flocculated suspension, here it shows the secondary minimum. Here the particles, they are separated by 1000 to 2000 angstrom through each other, and particles, they are loosely structured. Here the van der Waals forces that is present in between the particle, and they are easily dispersible, or we can say once they are sediment, then they are easy to redisperse. So if we are comparing these two, deflocculated and flocculated suspension, then flocculated suspension, that is very much good as compared to the deflocculated system. So here we have discussed about the characteristic of flocculated and deflocculated suspension, and also we have derived about the difference in between the flocculated and deflocculated suspension. Thank you for watching this video.